Hello there. Imagine that your team leader just asked you to reduce the total size occupied by your Docker images that are stored in your cloud service provider. What are you going to do about that? I will explain one solution in this video. So, when we are developing our applications, one of the things that we do to test them is to create containers. Our applications are usually developed in a JVM language, like for example Kotlin or Java or Scala, Clojure, even Groovy sometimes. But the point is, when we develop these applications, we want them to start and we want to see how they connect with each other. And if we have 1, 2, 3, 4, 5, 6, 7 more containers, we want to test the interactions between them in some way. And usually the way to do that is to deploy multiple containers and then launch different tests against them, which could be integration tests, regression tests, chain tests, end-to-end tests, and sometimes it's really each other's criteria to what we should name those tests. And when we use containers, one of the things that it's important to do is to store our images, and they are normally Docker images. And these Docker images we can use with Docker Compose or perhaps with Kubernetes in the form of pods. Those images need to be stored, of course, as I said, and they can be stored, for example, in a cloud environment. And different cloud providers have different ways to do this, but what's important here is to bear in mind that if we have one container and we create an image for it, we can then upload this image to the cloud, therefore enabling us to download that image and then spawn different containers of the different images we have. We can also use these containers to deploy to production. And there is always a problem if you are a developer and you want to test locally. It's just that you are downloading containers, like 1, 2, 3, 4, 5 containers. And if your containers are big enough, that is, the images are big enough, it will take time downloading and it will also take time to start. And sometimes those downloads can take 1 minute, 2 minutes, 3 minutes, 5 minutes, 10 minutes. It just will take so
It's a joyful day
long to download those containers. And that's horrible. That's a really horrible perspective because you're there to develop code and to see if your code works. You want to see if your interactions work, if your late changes work. And worse than that is that if you have a dynamic team, the more members of your team you have, if you have a continuous integration pipeline, every single time someone makes a commit, for example to the master branch, it will get deployed so that it can be tested. That creates another problem, and that is if you are testing in your branch and there are changes in master, and you need to merge those changes back into your branch to make correct tests, you also need to upgrade your containers. So that means, and that is horrible, because again, you're wasting time. And if you notice, I'm talking a lot about downloading, uploading, and just, this is all data traffic. You're pulling data from the cloud provider so that you are able to perform tests. You are also forced to make updates constantly. And if you are deploying to production, you are still needing to download the images from the cloud provider. If it's done directly in the cloud or locally, it's still data traffic. And this data traffic has costs, not only costs to download the data related to the containers, but also the cost of storing them. Because of course, if you have different images, now you need to store more space in the cloud to have those images in the repository. And this may lead you to think that there might be a tool or something that can make our images smaller. Now there are different strategies for that. One way is to, instead of using JDKs, which is something that many developers do when they don't know better, is to use a JRE. So instead of using the full Java development kit, it is recommended to use the Java runtime environment, which is generally smaller than the Java development kit. We can also use different combinations with the operating system they are running in, and we can select different kinds of images that provide a certain version of a certain JDK. But that is just something that can limit so much the container size. Another way that we can do this to reduce the image size is, let's get rid of libraries that we are not using, perhaps selecting of those libraries which transitive libraries do we want to use or not. And I'm sure that this has popped into other developers' mind before, at least to me it has. I always wondered if there was a tool that would be able to shrink the JDK size so that I wouldn't have to use all the functionalities of the JDK. But before we talk about that specific tool, we have to go back to 2017 when Java 9 was released. And during the release of Java 9, there was this book also released not long after, which is this one about Java 9 modularity. This is a very important concept to learn. This book was written by Sander Mak and Paul Bakker. Now, funny story, I bought this book before 2018 when I went to San Francisco to visit the first Oracle Open World Conference. And the funny thing is that I was at the presentation of Paul Bakker on that room, listening to what he had to say and explaining Java 9 modularity. And the funny thing is that at the end of the presentation, he literally gave out the book that he had written. So I felt a bit bad because I had to pay for this book before. But on the other hand, I was already prepared to listen to what he had to say in the presentation. And I have to say, it was a great presentation. And I learned so much about modularity ever since. But modularity is something that, if you don't work specifically with modularity and with those kinds of projects, the odds are that you won't hear much about modularity. And modularity, long story short, it just means that we are putting different packages in one module with a certain name. It isolates different packages under a different name. That was bad. I apologize. That was my Bluetooth audio player that I left on because I was listening to music before I started making this video, and that's why you just heard that sound. But back to the video. So I was talking about modularity. This video is split into two parts. The first part, we are going to have a look at how can we use JLink to shrink the size of our Java runtime environment. And then on the second part, we are having a look at how can we use JLink to use an external library to add functionality to our Java runtime environment. And the idea is that we are going to use modularity to it. And therefore, we need to understand what modularity is. So if you don't know what modularity is and how it works and how it looks like with Java applications, don't worry, I will explain how that works in the second part of this video. But for now, let's go to the first part of the video, which means that we are now having a look at how to use JLink to make our runtime smaller. So let's get into that. The example we are going to go through resides in GitHub, of course, and you can find it here in this repository right over here under my handle over here. So this is github.com, my handle, j.esperancinha, and then je-org-spring-master-test-drives. And you can find here the repository. You can then clone the repository. I already have it locally, and I have already IntelliJ opened so that we can start going through our examples. So let's go there, and here we have two different important modules. These are the validation company and the validation company's simple CDS. The CDS is over there because CDS is something that is available on Spring. I have made a video before about it, and CDS means class data sharing. These two were also used for that video to explain what is class data sharing, and I really advise you to go and watch that video as well if you are interested in improving startup times in your applications. Perhaps CDS may be a good solution for you, so I encourage you to watch that video. And for now, let's have a look at JLink and how it works with these two examples. The example at the top, so I've mentioned this before in another video, but I will mention it again for now if you are watching this for the first time. The validation company is a project that is implemented using Spring, and the one that has simple CDS is a simple Java application. So let's first start with our simple Java application. Inside, we will find a simple application that essentially just performs this. It will print out something to the console, it will print out a bunch of numbers, and then it will print out this if we activate this flag. We are not using this flag. This was only important when we were testing Spring CDS with these applications. For now, it is not important. There is a commented code over here, but we will have a look at this piece of code on the second part of this video. For this part, we are only interested in knowing how JLink works. And for that, before we start, let's first run JLink from the command line and see what we get. If we run JLink, we get the output must be specified, and we also get this message that tells us that we need to add some options to it and identify the module path, or perhaps add some modules. We will see how all of this works. For now, let's first have a quick look at the make file. And in this make file, I have already prepared different commands that we can call from the command line, and then we can run them and start getting knowledge from there and understanding how JLink can work for us for this particular case. The examples, the commands start right over here from JLink experiments, and here we've got copy JRE to local, JLink JRE, docker delete. These are all commands that I have given a name to them, and we are not going to run these commands. We will do everything manually from the command line. Once you learn how to work with these commands, then you are welcome to call these commands on your own, because they are made this way so that we don't forget how they work, but also that we have a reference to if we need to use these commands in our production environment, your personal projects, or anywhere you need them. So let's start by, not by this one, but let's start by the JLink JRE. The first important command here, because the rest is just pure management and understanding how can we, for example, here reach the original state of the application by deleting something that we are going to create just now. And then here, for example, checking the data surrounding the newly created JRE. Here we will get the size of it, and then here we will run our application quickly, and we will see if it works or not from this newly created JRE. But first, let's clean out the root directory. Remember this directory name. I will delete it now, the validation company JRE, so you already can get an idea of what will happen if we create this. Let's get rid of this jar as well. So we've now reached the initial state of the project. So now let's first run JLink as it stands in our make file. And one important thing On the first line is the module path. The module path is where we define where our modules are. Our modules are defined in the JMods folder of our JDK. It doesn't have to be this for every case, but because we are interested in creating a new JRE from our local Java installation, in this case the JDK, we then need to provide it with the location of the JMods folder in our JDK, which is why we use this environment variable Java home. I know that this application only needs the Java base module of the JDK. But if we are making more complex applications that, for example, need RMI, then perhaps we need to add that module to it. And if you are interested in knowing all the modules that are available in our JDK, we can just issue this command, which is Java, which is already in our path, and we only need to call this list modules switch. And if you call this, we see all the modules that are available in our JDK. And we only have to choose the ones that are necessary for our application to be able to run. And you can see we've got Java base right here at the top. So now we've selected the path of the modules, which is in JMods in the Java home. Then we are adding the module that we want, which is Java base. And then finally we define the output. This is the output where our new JRE is going to be generated. And it's that simple. The rest of the commands, it's just to be able to inspect what is happening when we create this new JRE. So let's run this from the command line right now. We have already deleted all of the temporary files that I've used in previous tests, and so we should be able to create this directly if we issue this command. So let's do that. So the command is JLink --module path. Then we should put here our Java home /jmods. Then we need to add the module that we are using in our application. This would be the Java base module. And only finally we can just say where we want our folder to be created, which will contain the newly created JRE. And this will be the validation company JRE, which we can give any name we want for our folder which contains this JRE. When we issue this command, it says the directory already exists. I apologize. I need to go back one step and then go inside the validation company, simple CDS example, and then issue the command. I didn't realize that I was in the Spring folder. We'll get to that, but that's further in this video. So if we run this command, we should now see from the IntelliJ file listing that there is a new folder created which does have the similar directory structure as a JRE. If we go here to the bin, we see that it has some essential tools installed, and it's got other stuff that is important related to our JDK. One important thing is that we never forget that when we are making these tests, that we are always using the same JDK to be able to perform correct comparisons. So let me show you that now. If we issue Java version, we see over here that I'm using eclipse-temurin 21. This is a JDK that is installed locally. I can use the runtime that comes with this JDK to run programs, but I will not be able to access the compiling abilities of the JDK with the newly created Java runtime environment. Let's now see what issuing Java version says inside the the newly created JRE. If we call that command using the validation company JRE /bin/java and then issue this command with the same switch version, we see that it says exactly the same. It's the same Java version. And this provides a runtime environment for Temurin 21. Now that we have this folder, it's probably a good idea to understand how big is this folder. And for that we issue du-sh and then the validation company JRE. And we realize that this folder is only 57 megabytes in size. Let's see how big is our JDK. And if we perform the same operation to our Java home directory and we simply issue this command, whoa, that doesn't seem right. Oh. Yes. Because, yeah, of course, because you need the backslash at the end. Then we see that it occupies in its totality 345 megabytes. So that is a huge difference. But this isn't something that we can really compare because we know already that the JDK is much bigger than JRE. That's just factual. And so another thing that we can do is find out the size of an image created with the JRE, a Docker image created with a JRE that it's downloaded with a Docker file. And that's why I've got a comparison between not just 2 different Docker images, but 3. I won't be downloading now the JRE that comes with the Docker image, but I will compare the total size of the Docker images once they are created. And now we have to go through the process of creating those images. So we need to compare what is happening here, which is the creation of our JRE, with, for example, building an image with the JDK. So if we need to compare an image that is created with this JRE with an image created with the JDK. And for that, I have right over here a Docker file that creates an image based on this newly created JRE, which will run the application. And then I have one current JDK Docker file, which will use this current JDK installed locally, which will be possible to be done because we are copying the current JDK to this folder. We will see that now. And then we also create the traditional way of creating an image, at least the ones that most developers are used to, which is just going to Docker Hub and downloading a convenient image, which in this case I'm using eclipse-temurin 21 to be able to compare it with the one I already have installed locally. So I've got one JRE that is coming directly from Docker Hub, and I've got 2 different images that are based on Debian Bullseye Slim. The idea is to use one image that provides me with an operating system in a container that then I can use to install the JRE or JDK of my preference and then run the application that I want. And they all share the same commands. So we just start the command java jar with the application and then it stops immediately. And we can also then measure the startup times of the different containers. We will measure the startup times with the current JDK, with the traditional way of creating images with the JRE, and then finally comparing with our own custom runtime. The makefile allows us to do all of this automatically. And so copying the JDK happens right over here. This will copy the current JDK to this folder over here. Then we've got another one which creates the traditional way of creating a Docker image. That's this one over here. It will build whatever is inside of this folder over here, which only needs to have our application, which is called the validation company simple CDS. And this is valid for all the other cases, for this one with the JDK, and this one for the Docker image, where we will copy the jar file. But in this case, we don't need to make a copy to a special folder. We don't need this intermediate step, because we can use the Docker file directly, accessing it to the build folder. We can do that because the Docker file is located on the root of the project, which has an access in subdirectories to the jar that we want to run. And that's why we don't make a copy. And this is valid for this project and for the Spring project that we are going to see later on. These commands are all chained with this one over here, the build JLink example images. But we haven't tried one thing yet, and that is creating the JRE, but then afterwards running the application. We haven't done that yet. Let's see now if that's possible with this JRE that we created. So for that, I will simply run the application, but I will need to build it first. And for that, we simply just run make. This make will just create the jar file by just using Gradle build. I can show it to you here at the top. It's a very standard way of creating a build. We are calling wrapper. I do this all the time just to create a new wrapper. If I have a new Gradle version, then I call this clean, which will clean temporary files. And then this one over here will just build, and the build command will perform a Gradle build, which actually also runs a clean here. This is for specific cases. If we want to call the build directly, it does perform 2 times the clean command, but that is just for convenience in this case. And therefore, now we've got all of this. We've built our jar file, and so now we can just go over here to the command line and just call Java again, but now instead of listing the modules that this JRE contains, well, that is actually something interesting. Why not list the modules that this JRE contains? If we go here to Java, to bin and then Java, and then we say list modules, we only have Java base. And so this JRE only contains Java base. And so the question is, will our application run now with only this module? It's very easy to test. And then to run our application from this JRE, we only need to run the Java command inside the JRE folder, bin, Java, and then we just call it with -jar because we are running a jar, and then build, libs, and then of course our application. And this should run now and print a bunch of numbers to the screen, accompanied with the previously output of hello world. And there we go. That's what we get over here. Hello and welcome with a 5 integer count. And so this just ran with our created JRE. So now we've got the JRE, we've got the Docker files ready, and that means that we can now run the whole example. Because now we have checked the size of the JRE. We even went as further to find out the size of the JDK, which is substantially different from the JRE, but that is a logical difference. And we have ran the application. Now the rest is something that, if you are familiar with Docker, then you already know how to do. The explanation of all of those details could be important, but it's out of the scope of this video. So maybe I will do a video about creating Docker images maybe in the future. But for now, let's just continue and run the commands that I created that will create the 3 different images, and then we can compare both of them, and then we can see if they run or not our application anyways. So the way to build everything in one go is simply to run build and then JLink example images. This will build all 3 images and push them to our local repo. Let's build them up, and it will run the application in the steps between for the JDK and for the JRE, but not, of course, for the one that installs the application in the Docker image with the custom JRE as a source image. Not the bullseye image, but the source image of eclipse-temurin JRE 21. Okay, so we have created all the images. I have another command at the end of this file, which is called show JLink images. This will give us a summary of the images that are installed now in our machine. And let's see what it says. If I run make show JLink images, it will run this Docker images filter with the validation company named images. If you look at the previous commands, you will see that the command for JLink creates an image that is called the validation company. The command for the simple JDK image with the current JDK attribution has the name of the validation company current JDK, and the last one has the JRE, and it is pushed with the name the validation company traditional JRE. Let's run the command and see what just happened, and let's interpret it. So the last row, which is the one that we used to create an image based on the new JRE, has a size of 142 megabytes. And we can see that the traditional way of creating JREs allows us to create an image that has a size of 289 megabytes. And then finally, with the current JDK, which is expected to be the biggest, is now using 442 megabytes. Let's put this into perspective. Traditionally, we are used to using an image. Many developers will not consider using a JRE or a JDK. The idea is just to get the application to run. And because we are talking about differences sometimes of only a couple of megabytes, and a couple of megabytes can mean to some people 100 megabytes, it's not enough argument to consider choosing between different images, which relates to the problem that this video is focused on, which is size, of course. But we can see that if we use that JRE, we are already sparing about 150 megabytes, maybe 200 megabytes even, between using a fully installed JDK or using a JRE. But if we go a bit further and use JLink to create our customer's JRE that works with this application, then we save an extra perhaps of 150 megabytes, which means that in total we can save about 400 megabytes if we use this wisely. 400 megabytes, consider this, 400 megabytes out of one download alone, because these images usually are stored in the cloud and we need to download them to do things. Those could be in the pipeline, those could be locally, those could be between developers. So if you have a team of 10 developers, that already means at least 10 downloads every time they need to use the images. 10 downloads already means 5 gigabytes. If they are making multiple tests a day in a continuous integration environment, those images can be 10 times more or 20 times more. Let's say if we have an active team working, that would be about 20 times per developer. Let's say 20 times per developer. Now I've got 20 times per developer, a team of 10. That's 200 times per developer. You can already see where this is going. If it's 200 times per developer, and we've got around 400 megabytes of saving space, that means 800, that means 80 gigabytes in one day. Think about it. Isn't it important to save 80 gigabytes per day? Because this will have an influence in the pipeline. This will have an influence in the way developers work. Think about it, 80 gigabytes. How much does that cost in a cloud environment just to upload and download? And if you happen to have a free tariff plan, it doesn't matter. It's hurting productivity because all of these things are being fired against the cloud service. So that means that if you are working in a company and everybody's making downloads, or the pipeline is making downloads, it's going to slow down. And that means productivity gets an impact over it, even if no extra money is being spent on saving space. Time is money, right? Time can save a lot of money as well. So if we can save time downloading images, here's your argument in this case. And this is just for a simple example. In this example, we see that we have saved a ton of space, perhaps per day. 80 gigabytes. Memorize that number. All right, but this can also be used in a Spring application. And using a Spring application is really where the interest of using this comes from. Now, the example for the Spring application, as I mentioned before, is located in the validation company module. And the validation company module already has everything installed considering Spring. Also, all of this that we have done. This part here below is related to the second part of this video where we will talk about modularity in our own customly made JRE, but with extra features that we have added to it. But that is for the second part. To finish off this part, let's have a brief look at what we have created here for the Spring example. If we look at the make file, we see very similar commands as we have seen in the simple CDS example. But there is a small difference. Because these are Spring applications, they will keep on running. And to test between, to make those tests between to see if the application actually runs, I am starting the application with this switch over here. And that only means that the application will start. And once it has started, it will suspend, it will stop, and we will be able to continue. This is handy here because I just want to see how long it takes to start the application. And that reminds me of one thing that we still didn't do, which was to run the startup times. So let's do that. Let's run the startup times script and see if there's any difference in starting these containers from these images. Because here's the thing, when we talk about CDS and GraalVM, we are talking about ways to enhance our startup times, to make the application start faster. And sometimes there's this idea that because JLink shrinks the size of the Java runtime environment, it will somehow make the application start faster. If we look at what we've got after running this shell script, we see that the JDK started in 556 milliseconds, the traditional JRE started in 516 milliseconds, and the validation company with our custom JRE actually took longer to start. But if you look closely, these numbers, if I run them, if I run this script multiple times, these can vary a lot. And perhaps, because we are using indeed a lesser amount of modules, maybe we can get some kind of benefit in terms of startup times. However, that benefit isn't measurable in this case. Perhaps in bigger applications, perhaps, but it's not something that JLink guarantees. What it does guarantee is saving space and allowing to create custom JREs. So let's now do the same example in the validation company with the Spring application, which in this case, since it's all the same thing, that means that we can start the application in the same way with the script that I've mentioned before, build JLink example images. It will build the linker image, it will build the JDK image, and then finally the traditional JRE Docker image. We can have a quick run through, but not in too much detail because we already know how this works for the other application. It's the same thing. So here we've got the example that creates the JRE, the custom one that we need. And this uses JLink, and it adds all of these modules. But wait, here's the interesting part. For this application, it was a bit more complicated to find out which modules are necessary to run it. And therefore, this was done a bit by trial and error. So I'll give you an example. If I am running the application right now as it is, and I use JLink to build the JRE, this will create the JRE for me. Let me just first delete the folder that this automatically creates when you use the JLink command. Let's just generate this first. And now we can run the command JLink, and for that we just do JLink and then module path. The only thing is that here we cannot use parentheses because we are in the shell command line. So therefore we can just use Java home. And then I believe we can just copy the rest. And then this should work. Yes, it says the directory already exists. So let me delete it. There. So now we've got the new JRE right over here, and we can see that it worked. And if we now run the application from it, we can see that it's also going to work. Let me just start it. If I use the path to it, bin and then Java, and then the path to the application, this will be -jar build and then libs and then the application. This should work now. And there we go. It is working right now. I didn't told it to stop. Let me just now stop it manually. If we now want to run this application with a shorter version or an even shorter version of the JRE, it might not work. I'll give you an example. If I push that command again to my console and then I simply remove, for example, something that we may think it's not necessary. For example, the JGSS module for security. If I remove that, and yeah, first I need to remove the JRE, of course. If I remove that and I try to build the JRE again, it will build. We have a new Java command there. And if we try to run our application from that new command now, we should be getting a problem. And the problem is a class loading issue. And normally it says specifically which class is missing because we did not add this to our module, to our collection of modules for our new JRE. And therefore it's just a question of try and error. You usually start with Java base and then you need to follow the outputs of the console and the error messages that are coming through. So if the class is missing, we need to find which module does it belong to. And therefore we can just pick up, for example, here it says that it misses the class GSSE exception or GSS exception. We don't have to know what it is, but if we open our browser and if we go to Google, for example, and just simply look for it online, we will find it over here, for example, but the best place to look at is via a modern version of Java, and we can look at it right over here, GSS exception. It belongs to module Java security JGSS. Recognize that? That was the one we just removed. So therefore, the fix is simple. We can just simply remove the JRE now, and then rebuild it again. But now, instead of using this command line where it doesn't contain the module that we just saw, then we just go back a few lines back, and then we see that this one already has Java security JGSS, and now we've got our new JRE available in our root folder of our module, and then we can just go over here and then start running our application, which is run perfectly because it has exactly the modules that it needs. All right, so this tells us how the JRE works, how it's going to be built, and it tells us how can we run our application using it. But we can see that we have added more modules. So the question is, what benefit are we going to reap from using JLink to create our own custom JRE, in this case where we need more than one module? Let's give it a try, and for that I will just run the full command for the build of all our images. That is build JLink example images, and now it's just going to do everything. And in this case, because we are using the make file, and because I've made this so that it can run several times, it will also delete the temporary folders that it creates. So that manual step of removing a JRE, for example, it's something that it already does automatically for us. Now we've got all our images now, and they're all been stored in our Docker repo. Let's see what is the size of the images that we got. Now, in this case, we also have a show JLink images command, and it simply filters all the images from Docker with the name the validation company as a prefix. Let's see what can we find. Let's run make show JLink images. We've got 3 images as we expected. They all are now called the validation company without the simple CDS there. So we know for sure that these are the new images that we are comparing or performing these comparisons. Then we see that the validation company, the one that we created in a custom way, now uses a size of 216 megabytes. The current JDK, of course, is the largest one. It uses almost 500 megabytes. And the one where we use the traditional way of creating images from the perspective of a smart developer, we use a small JRE and we create our Docker images that way. And then we see that it occupies the size still of 319 megabytes. We can say here that from the JDK up to the custom JRE, we are looking at a space saving of 200 megabytes. This is quite big, because if you look at it, and let's now make the calculation comparing just the JRE and the validation company. Let's say roughly 100 megabytes. That's how much we are saving. In the example before, that's 100 megabytes of download times 10 developers times 20 times a day. So that means just about 200 times 100. We've got there about 20 gigabytes of saving space. Let me check around again. We've got, we are saving 100 megabytes per download times 10 developers. That is 1 gigabyte already. And of course, then times 20, that is 20 gigabytes. In any case, it is 20 gigabytes a day on a normal day, on a day with normal activity. So there we can see that this can really mean a lot depending on how your continuous integration of continuous deployment is being made and how users use the images that are being created in order to communicate between the different containers. This is a way we can see that JLink can be very beneficial if you are really using this amount of downloads and if we need to update images a lot of time. Of course, if you are using the same version of the same containers, you won't be needing to download them all the time. But that's not how a development environment works. Most of the times, if something changes in one of the containers that uses the other containers, and that there is some kind of codependency between all of them, then of course you will need to update your containers. And therefore, there will be space that will need to update. And of course, it doesn't mean that we are going to use the 80 gigabyte space, because when we update a container, it doesn't necessarily mean that we need to download everything back. It kind of segments the containers. That's part of the way Docker works. Now, all that's left to do at the end of this part is to find out if there is any benefit to the startup times in our applications when using JLink or not using JLink in between the different kinds of images that we have created. And for that, of course, I have here another script that is also called startup times. So I conveniently made everything the same so that it is easy to use also for you when you run these tests on your machine. Do that. It's really good if you run these tests on your machine, and because then you can understand better how everything works. If I now run startup times and read the output to the console, then I can see that the first image now started in roughly 2 seconds, the second in 2 seconds, and the last one in almost 2 seconds. There is almost no observable difference, and it actually feels like that the one that took longest to start was our custom created image, which you can see here took about 2.1 seconds, and the other ones is 2.0, 2.073, but these are very small differences between them, because if I run them again, we are probably going to get very dispersed results. And as we can see here, now it took 1.6 seconds, then 1.6, then 1.6, and you can see that the difference is very small, and now it was the traditional JRE that took longer to start. So there is really no conclusion also here about the startup times, because that is not what JLink is intended for. It is intended to save space, essentially just that. Of course, undeniably, there could be a very small benefit in terms of startup times, just because there are less classes being used and of course less modules being used. But that usually does not represent a huge difference when starting an application in Spring. Alright, so this was about JLink, about how can we shorten our JRE and how can we save space in our containers. Let's now have a look at the other part, which is the second part, which I hope you find it interesting, which is about modularity, of course. Modularity. Why is it so important to use? Well, modularity in general terms is a long topic, and so why is it important to use? There are a lot of benefits to using modularity. One of the benefits is to use them here with us to add extra functionalities to our JRE. So for that, it is important that we look at one module that I created specifically to illustrate this possibility using JLink in our JRE. First, we create a module with the functionality that we want to use there. I called this a print module. And in the print module, what I simply created, this is probably one of the simplest things that you can possibly ever see in code, is just an example that just prints something to the console. And we've got here one, which is auxiliary, and the auxiliary method is this print Java to console, which essentially just returns a string with this is a and then a sentence. This is a simple Java code. And with the simple Java code, we have this simple instruction that we want to use now as a part of our JRE, but not exactly as a part of our code, which is where the possible benefit comes from. So what we need to do to make this work is first add a module-info.java. Now, module-info.java, if you are not aware of how modularity works, this sounds like a very bizarre class, and it is in a way, but the name must be this one. Module-info, and yes, in small letters, and yes, with a dash in between, which seems to break all the rules of camel case, but that is something that is done this way. Why it is done this way, I don't know very well, but this is how we create a module in Java. The module is called j.module, and then we export the functionalities that we need in the module. These are functionalities that are usable when we import this module. Everything that is not exported is available, but on a private level. We cannot use it from the outside, but our functions can. And we also mentioned that this module requires kotlin.stdlib. This is the standard library module that allows us to create applications with Kotlin and allows us to create a module that can be usable in a Kotlin application, or in this case, a JRE. We can have a quick look at the build Gradle KTS file, and here at the bottom we can see that we have enabled info-module path modularity. This is important so that we can export this module with the Kotlin classes that are necessary for us to create our module. And another thing that is important for this module to work is to be able to export the jars that are necessary for it to work. In order for us to be able to use this created module in our library, in our JRE, we need to be able to also export the different jars that are necessary so that it works correctly. And that is something that we will see right now if we build our application. Let me just go here to the root. If I go here to the root directory, actually I'm already there. If I go to print module and I do a make, this is now going to build our module. And it's important for us to realize what the result is of building this module, because you will see that because of this copy Kotlin standard library task, we will find that in the build folder, we will see in libs that we've got the annotations jar, the Kotlin standard library jar, and also our print module jar. All of these are important to put in the class path when we create our JRE, but I will explain that further. Now we've got our module. It is created and it is created here. Let's now go back to our simple application, our simple CDS application, and there we will look at the code and we'll make something very simple to our code. We are going here to the simple CDS application and we are going to uncomment this line of code, and we will see immediately that IntelliJ complains about it, that it is not compilable. Of course, IntelliJ is going to say that because IntelliJ is not ready to work with these JREs. And it's difficult to configure it. I tried and I could not configure IntelliJ to work with this. So what is the alternative? The dreaded command line only. And therefore, that is what we're going to do. We are going to compile this application in a way that uses the custom JRE Java runtime environment, and it will be able to run on that Java runtime environment. To compile this, we are actually not using the JRE, of course, because that is not possible. This is not a JDK, but what we can do is use the class path where these jars are located, also where the module is located, to compile our application. So to get this to work, the first thing is, of course, compiling our application. That's what I've just mentioned. And so we can go here to the make file, and there I've got one first try that I did to try to get this to compile using the Java command line. That unfortunately didn't work, which is with this command Gradle build stack trace. This would use just a normal Java command line to compile the Java C to compile our code. That isn't happening, but we can use Kotlin C to compile our application. So the way it works is we call this compile with external command, which I customly made for this to work. And what we need here is to first indicate where we want the jar to be compiled to. then we need to declare the class that we want to hand in so that it finds the classes and modules that it needs to work with to compile our application. In this case, it's this one, the print module jar, the Kotlin standard library, and then, of course, we need to mention where is our runnable class, which is the simple CDS application. If we go to the command line now and we run make compile with external, it should compile correctly. That's what we've got now. And then we can go over here and see that we've got an app.jar file. This is our compile code, not with IntelliJ, but with our command line. So it worked. We've got it compiled, but does it actually run? It probably runs, but we need to add the functionality of our application, because if we just make the JLink JRE like this, it fails. But it fails now because, of course, it doesn't have the validation company simple CDS compiled. It's not using the app.jar. But we can now try with the build JRE, because it was successful in that. And now if we go to the validation company JRE, and then we go to bin, and then we go to libs, and then, sorry, if we go to, and then we go to Java, and then we do dash jar, and then we try to run our application app.jar, we will see that it does not find class intrinsics. That's the first error that it shoots out to the console. This makes sense because not only we are trying to run this application with an incorrect JRE, but also it is not able to interpret that package. And so what can we do here? Well, we should be able to add the modules that it needs. And hey, one of the ways to do that is simply to improve our JRE. And for that, we just create the JRE with the JLink command, but now we use the feature JRE. If we go here to where the command is declared, it's this one over here, and here we can find that it has added the modules Java Base, Java Desktop, Java Management, Logging, Instrument, and the module that we have seen before. We can see over here that this is the name of the module that we have given in the print module. And if we go there to the module just to double check, and I will put it side by side for you to be able to see it in more detail. Let's now put it this one over here, and let's get to the make file, not this make file, this make file, and we can see that this is the module that we need, which is this one over here. Now, this is just a declaration of the modules that we are going to use, and therefore now it knows that it will have to use these modules. But the declaration of JLink is not the same as before. There is an extra element also here, not just the base modules, but also the module path. And you can see that the module path that I've added also is the folder of the libs, the output libraries that our Gradle build creates when we run it from the print module, which is what we find over here in the build and libs. So these three become a part of the class path to be able to generate the JRE that we need. Now, we have already typed in the command, which is this one, make JLink feature JRE. And when we run it, it should now create the JRE. It doesn't have the validation company simple CDS jar. I should actually fix that now. Let me just do that. It will be app.jar, I believe. That is the name we've given it to here, app.jar. And so let's just run it again. And we can already see that the application runs. We don't even need to go over here to this command run with external, because it simply runs already. So what we have achieved right now is the ability to run this application with a JRE, which has now an added feature to it, a simple feature. It's now running, but as we can see, we are missing something. Let's have a quick look at our application. Our application is simply calling this method, print Java to console. Now, one thing that we need to have a look at is the code. Now we can see that our application is running, but let's see if it runs in the normal Java runtime, because this just ran with the custom runtime. So if we do java-jar and then app, it will complain that it doesn't have internal asynchronous again, because we have done this special JRE in order to be able to get this application to work. Now, if you've noticed, and if I do run this again, we see that it does not print what it is supposed to print, at least what we expected here. And the reason for that is very simple. It's because that's not what the code does. This just returns a string. To get this to work, let's just print this to the console using this print line simple command, which we shouldn't use in production anyways. But if we do this and we call the make compile with external, let's have another quick look so that we can try to at least memorize what it actually does. It calls Kotlin C, the command, and then it uses as an output an app jar. Then we define the class path where the jars can be found. And then finally, we tell the compiler, the Kotlin compiler, where our main class is located. And this then creates a new app jar for us that we can then run. But before I run it, now let's have a look again at the way we create the JRE with an extra feature. We run JLink with the module path, and then we add the modules that we need with our custom module added to it. And then finally, we just try to run the application right over here, having previously made a check of the size of the image. But that's not important for now. Important here is that we are trying to add a feature using modularity to our JRE. Okay, so now the JRE has been created already with only the strictly necessary modules. It will take a lot less space as we have seen before. But now it's time to see if it will print out what we expect to the console. So if we do make run with custom external, which is the one we have seen here at the bottom, it should now run the application with the command, and then it will print out this works. But the thing is, we can run this directly without defining any class path like I have defined here. So if I say the validation company, and then I go to the bin folder and I try to run Java, and here I try to run the jar that we have created for app jar. If we run this, it still runs. So we can see that we were able to run an application and compile it using the external module, using the Java C command line, or in this case the Kotlin C command line, and we were able to create a jar that only runs now in our custom JRE. This can have multiple applications. For example, if you want to create events in the JRE that you find it important for your application, there are, unfortunately, at least not that I know of, good tools for this. So this kind of implies that you are very, very, very familiar with syntax, and that the IDE doesn't necessarily have to play a huge role when you are typing code. This could be interesting for small processes where it is very predictable what they do, and that we can easily compile them. If there is a tool that then can interpret this correctly and can really get our code to work using just the IDE, then perhaps this can really take off really well in future applications. This was a two-part video where we first saw how can we apply JLink to our applications to reduce the space of the JREs, and on the second part we have seen how to add a functionality to our JRE and work with compiling code using the modules that we add to that JRE and find out just how it works. I hope this video has been instructive for you. JasperTech has reached 500 subscribers this year. This is a huge milestone, and I thank you enormously for following the channel up until this point. I know that you have found the quizzes very interesting, that I see in the comments. I really love the discussions that we have been having up until this point so far. You are really a great crowd, and I hope I get more people interested in this channel, because it's just going to get better from here onwards. I have a lot of plans for this channel, including a fixed programming, and one of the things that I am planning to do with this channel is to make sure that we get at least 5 quizzes a day. This is a habit that I need to put in my routine, and every Wednesday there is going to be a new video, a new long form video for this channel. I think I will set up the time to 5 o'clock in the afternoon, 5 p.m. and I will also create one article per month to support this channel and to provide you with more knowledge. Now, I'm already about 4 articles behind in terms of also video making, so hang in there. They will all come up. Now, the changes to this channel, the rollout to these changes might take a while. It might take a while to feel that we have reached a certain kind of pattern, but that is the idea. Occasionally, there will also be another program on Sundays, and it will also be at 5 p.m. I hope to see you in these videos, and I hope that you join me in this journey with JasperTech and this channel. Finally, I would like to say thank you so much for watching. Thank you for watching this video up until this point. Congratulations for learning so much on JLink if you didn't know this already, and if you did, I hope this was a good time for you to review your knowledges about JLink. If you have an opinion, and if you can tell me please a way to use these pieces of code that we can make with modularity with IntelliJ in a seamless way, please let me know in the comments about that. Please comment on the general format of the video and if you've enjoyed it so far, and I hope to see you on the next video. And until then, thank you very much. Don't forget to leave a like and subscribe to this channel, and stay tech, keep programming, be kind, and have a good one. As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.